अस्सलाम वालेकुम स्टूडेंट्स। इस वीडियो में हम एक एग्जांपल देखेंगे which is related to the radial and transverse component of velocity and acceleration. The question is that if a particle p moves in a plane in such a way that any time t is distant from point O is r is equal to at plus bt square. It may look like this one. Let's say we have this origin, axis, and here we have a point p. So this point P is the distance of this point P from the origin is at plus bt square, and the angle is ct power 3 by 2. So we have to find the radial and transverse component of velocity and acceleration of particle when the time is equal to 1. As we know that the radial component of velocity Vr is equal to dr by dt, and transverse component of velocity is equal to r d theta by dt, whereas radial component of acceleration is equal to d square r over dt square minus r into d theta by dt का square, whereas the transverse component of acceleration is 2 dr by dt and d theta by dt plus r d square theta over dt square. We have r is equal to at plus bt square and theta is equal to ct power 3 by 2. So first we have to find dr by dt. This is equal to a plus 2bt, and then we have to find d theta by dt, which is equal to 3 by 2 ct 1 by 2. We have to find the radial and transverse component of velocity and acceleration when t is equal to 1. So dr by dt when t is equal to 1 is a plus 2b, and d theta by dt when t is equal to 1 is 3 by 2 c. Now take second derivative, d square r over dt square, which is 2b, and d theta by dt, d square theta by dt square is 3 by 2 into 1 by 2 ct 1 by 2 minus 1, so this will be equal to 3 by 4 ct power minus 1 by 2. And we have to find when t is equal to 1. So d square r over dt square is 2b, क्योंकि t की कोई वैल्यू इसमें नहीं है, तो this will be equal to 2b. Similarly d square theta over dt square, t को जब आप 1 पुट करेंगे तो 1 की पावर minus 1 by 2 is 1, so this is again 3 by 4 c. Now the radial component of velocity is dr by dt when t is equal to 1, so this is a plus 2b, and the transverse component of velocity is r d theta by dt. So value of r is at plus bt square, and at t is equal to 1 it will become a plus b, so a plus b, and value of d theta by dt is 3 by 2 c. So these are the value of radial and transverse. So these are the radial and transverse component of velocity. Now we will find the radial and transverse component of acceleration. ar is equal to d square r over dt square minus r d theta by dt square. Now d square over dt square is 2b minus value of r is a plus b when t is equal to 1, and d theta by dt square is 3 by 2 c square, which is 2b minus 9 by 4 c square a plus b, and transverse component of acceleration is equal to 2 dr by dt and d theta by dt plus r d square theta over dt square. So this can be written as dr by dt is 2 into a plus 2b and d theta by dt is 3 by 2c plus value of r when t is equal to 1 is a plus b, and d square over d theta square is 3 by 4c. Now after simplification we can write this as 3 by 4c 5a plus 5b. So these are the radial and transverse component of acceleration. Thank you very much.